So for the first one, you have an arc secant, which is not on the unit circle, but you know that it's a reciprocal of cosine. So if you want to rewrite it as arc cosine, then you can take the reciprocal of the inside, which would make it 3 over 2 root 3. So the reciprocal of secant is cosine, and the reciprocal of your ratio is this one. And so now I still have an equivalent expression. And I have to rationalize it, so I have to multiply it by root 3 over root 3. So I have arc cosine times root 3 over root 3. So what is root 3 times root 3 going to give you? That's going to give you 3, which cancels with this 3. So this cancels, and now I'm just doing arc cosine root 3 over 2. So then you turn, go ahead.
Two fractions in one parentheses right up there?
So I have this first fraction here, right? One fraction. And then in order to rationalize the denominator, I multiplied it by root 3 over root 3. All right, so now I'm going to figure out what angle has a cosine of root 3 over 2. And you turn to the circle that's tattooed in your brain. And
Cross out the 3 on the top.
Yeah, why did you cross out the 3 on the top?
oh, because root 3 times root 3 is 3, right? This one is going to make a 3. I could have shown one more step with that.
Oh.
Okay, and so that 3 will cancel with that 3. So these don't cancel with each other. This altogether cancels with this. Does that make more sense?
Yeah.
Okay, sorry about that. I should have shown another step. All right, so which is the angle that has a cosine of root 3 over 2? It's on there. 5 or 6, right, which is the same as 30 degrees. Okay, so I'm going to do, maybe I'll do a cotangent problem, because I can actually do cotangent differently. It doesn't really make any sense to figure out the tangents y over x and then do the work of flipping it. You might as well just do a cotangent problem as x over y. So cotangent is x over y. You just have to remember that you have a different interval for cotangent than tangent. Your cotangent answers are between 0 and pi. So you're looking for the angle between 0 and pi that has a cotangent of negative root 3 over 3. In the beginning, before you know these better, you might just be doing a little bit of guess and check. So tell me an angle you want to check and see if it has a cotangent of negative root 3 over 3. It doesn't have to be right. We'll just check and see if it is. Is it going to be first quadrant or second quadrant? Why would it be second? Because it's negative, it's going to be in the second quadrant. Okay, and then what do you guys want to pick? I'm going to say probably not 135, right? So pick one of the others.
150.
Okay, we're going to pick 150 and we're going to check it. Okay, so check 150 degrees. So I'm going to do x over y. Those cancel, and I get negative root 3. So was it 150? No, but we checked it and it wasn't right, so not that one. What should we check now?
120.
Check 120. So let's check 120. So x over y. I have negative 1 over root 3. Now what do? Does it look the same? Good. If I rationalize it, will I get the same thing? Negative root 3 over 3. So that means the answer to our inverse cotangent is 120 degrees, or 2 pi over 3. Okay, so I'm going to pause for a minute and ask you guys to try to think through the remaining problems here before we go on. All right, guys, I want you to compare your work to Mambaya's work. Let's look at problem 2. In problem 2, he changed inverse cosecant to inverse sine and took the reciprocal of negative 2. And then he just had to figure out what angle had a sine of negative 1/2. Remember that you're answering between negative pi over 2 and pi over 2. So that's why you chose negative pi over 6 or negative 30 degrees. For the next one, again, he changed it to arc sine, and the reciprocal of 1 is tricky because it's 1. A lot of people think that's just too easy. It has to be wrong, but it's not. So then you have to think, okay, what angle has a sine of 1? And that's pi over 2. Questions on 2 and 3? Okay, then for number 5, he changed inverse secant to inverse cosine and took the reciprocal of negative root 2, which he did the work up here, but it's negative root 2 over 2. And then he figured out the answer has to be between 0 and pi, so this would be a second quadrant answer of 3 pi over 4. Any questions so far? Notice how many...
Was number 5 changed to cosine, the inverted cosine?
Yes, so this inverse secant changed to inverse cosine, true. Notice how many angles and ratios repeat on your paper because there just aren't that many numbers on the unit circle. So you're going to see a lot of repetition. All right, when you turn the page, we're doing something kind of new. I'm going to explain it. But any questions on this before we go?
So number 5, can you explain?
Number 5, the reciprocal of secant is cosine. So we changed inverse secant to inverse cosine. And then we took the reciprocal of negative root 2. So Mabaya did the work up here where he flipped it and then he rationalized it and he got negative root 2 over 2.
So then 1 over negative, so negative 1 over root 2.
So negative 1 over root 2 was the reciprocal, but then he rationalized it. Okay? And then he found it on the unit circle. Negative root 2 over 2 is over here at 135 degrees, or 3 pi over 4. All right, let's all turn the page. Let me pass that back to you. Thank you for sharing it. All right, when we work these problems, here's the most important instruction. You want to start on the inside. Inside, out. All right, I'm going to do the first row, and then I'm going to give you some time to work up until here. What is the sine of pi? Start on the inside. Yep, sine of pi is 0. It's right here. So this becomes 0. So it's arc, cotangent, 0. Then you're thinking, what angle has a cotangent of 0? I think you're right. So remember, cotangent's x over y, and one of your classmates just suggested it was pi over 2. So let's take a look. If you do x over y, that does give you 0, so the answer is pi over 2. Okay, so a two-step problem. Start on the inside, answer that question, then answer the outside question. Who has a question on number 1? All right, number 2. Start on the inside. We have to find out what angle has a cotangent of root 3. So again, with tangents and cotangents, for a little while they're guess and check, but you do know that it's which quadrant? First quadrant, because it's positive, right? Okay. So let's look at the first quadrant. Give me a guess. I'll check it. Pi over 3. This one's 60? So cotangent is x over y, so that would be 1/2 over root 3 over 2. Okay? So we checked it. We got 1 over root 3. Is that going to simplify to be root 3? Okay. So we checked pi over 3. Let's check pi over 6. See if that one's it. That would be root 3 over 2 over 1/2. Does that give us root 3? Good. Okay, so the answer for the inside part was pi over 6. And now I'm doing the sine of pi over 6. Remember, sine's the y value, so what do we get? Here's pi over 6. What's the y value?
1 over 2.
1/2. Yeah, 1 over 2 is the same as 1/2. Okay, question on 2. All right, Jalen, hurry. Problem 3. You start on the inside. So on the inside it says sine 3 pi over 2. 3 pi over 2 is not between negative pi over 2 and pi over 2. How come I'm allowed to say sine 3 pi over 2? Because it's not inverse, right. So you can still do regular trig functions on the entire unit circle. It's only the inverses that are limited, okay? So sine 3 pi over 2 is down here. I want my y value, which is negative 1. So I'm doing inverse tangent, negative 1. All right, so inverse tangent, if it's negative, which quadrant is it going to be in?
3 or 4.
Yep, it's going to be in the 4th quadrant, and I need something that when I divide the y by the x, it gives me negative 1. Yeah, so this one right here, if I divide the y by the x, it's going to give me negative 1, and we need to name that negative pi over 4 instead of 7 pi over 4, or negative 45 degrees. Okay? All right, so I'm going to pause for a minute so that you can ask questions on those, and you can try the other problems up through 12. Once you finish with 12, the approach changes because they're not unit circles. Number 4, cosine of pi over 4 is root 2 over 2. And now you have to figure out what angle has a sine of root 2 over 2, and it happens to be the same angle we started with, right? Pi over 4. So sometimes that happens just because the coordinates repeat for pi over 4. Next one, you have arc cosine of sine of negative 4 pi over 3. A lot of people had trouble with that angle because it's not on your first unit circle here. But what you can do is find a coterminal angle by adding 2 pi. So negative 4 pi over 3 plus 2 pi with a common denominator is negative 4 pi over 3 plus 6 pi over 3. And that gives you 2 pi over 3. So we're trying to find the sine of 2 pi over 3. So I'm just going to change that. So sine's your y value. 2 pi over 3 is right here, so it's root 3 over 2. And then you want to find out what angle has a cosine of root 3 over 2. And is this one 30 degrees? Okay, in this problem, a lot of people recognized that inverse cotangent and cotangent, maybe they're going to cancel each other out. But there's a problem because 11 pi over 6 is not on the range for inverse cotangent, so that can't be an answer. So you can still go through it step by step, or you could think about what would be an answer for inverse cotangent 11 pi over 6. So 11 pi over 6 is in the 30 degree family, and you know that inverse cotangent is going to be between 0 and pi, so you might be able to reason out where it's going to be. But if you want to do it analytically step by step, you have to find the cotangent of 11 pi over 6, which is going to be x over y, so that would be root 3 over 2 over negative 1/2, which gives you negative root 3. And then you're going to do inverse cotangent of negative root 3. For inverse cotangent, your answer has to be between 0 and pi, so you know that's going to go into the second quadrant. And because you were in the 30 degree family to start with, you might guess it's going to be the 30 degree family again, and it is. It's 150 degrees or 5 pi over 6. Okay. So I'm going to stop here for a minute to give you 2 more minutes to work, and then we're going to go over the rest of them after that. Okay, so for 7, you found the cotangent of 5 pi over 3, and it was negative root 3 over 3. And then for inverse cotangent, your answer has to be between 0 and pi, so you had to choose 2 pi over 3. Now notice, cotangent and inverse cotangent, you think they might cancel out, but the problem is that this angle is not between 0 and pi, but your answer will be in the same family. It'll still be in the pi over 3 family. So it's kind of easy to take that shortcut if you're sure you know what you're doing. For number 8, let's see, sine of pi over 3 is root 3 over 2. And then you're doing the inverse cosine. So the angle that has a cosine of root 3 over 2 is pi over 6. And number 9 is special because the arcsine and sine, they were finally able to cancel each other out and save yourself a step. The reason why arcsine and sine could cancel out right there is because pi over 4 is on the range for inverse sine. So that's allowed to be an answer. So if you have an arcsine and a sine, and the angle here is within the range for arcsine, then you can just cancel them and take that answer. So you can take that shortcut. That happened again in number 12. I actually solved the problem the long way, but again in number 12, arctan and tan, they canceled and gave you negative pi over 4. In number 10, let's see. Oh, in number 10 it happened as well. You could cancel the cosine and inverse cosine. And I think number 11 I can't quite see. So inverse cosine negative root 3 over 2 gives you 5 pi over 6. And then the sine of 5 pi over 6 is 1/2. Okay, so that's everything. What questions do you have on 1 through 12 before we move on? Okay, 30 seconds with this. Remember the key is already on Blackboard if you need more time with it. And then we're going to go on to the next section starting with 13. So you can tell that these numbers are no longer unit circle numbers, so we're going to draw a picture for each one. For arcsine, I'm going to draw it in the 4th quadrant because it's negative. Okay, this is theta right here near the origin. When I have an arcsine of a ratio, that entire expression represents theta. So this entire expression here represents theta. So this is my information about theta. I have some angle, and it has a sine of negative 2/3. So sine is opposite over hypotenuse. And we're going to do Pythagorean theorem to find the missing side. So I have negative 2 squared plus x squared equals 3 squared. All right, and is it going to be positive or negative root 5, guys? Look at your graph. Positive or negative? Positive, good. Okay, cotangent is x over y. So what will my ratio be? Look at your picture with x and y. What number is the x? Root 5 is the x, so root 5 over negative 2. Next one has a sine of negative 1/5. So again, sine is negative in the 4th quadrant. Bless you. So there's your theta. Sine is opposite over hypotenuse. And we're going to do Pythagorean theorem to find the missing side. All right, so when you do square root of 24, you do want to simplify that radical. I do it with a factor tree. Some of you have a different method. As long as you can simplify your radical, you're good. I do 4 times 6, 2 times 2, 2 times 3. So because there's 2 2's here, that can come out, and I'm going to get plus or minus 2 root 6. And in this case, is it going to be positive or negative for my x? Positive, so it's positive 2 root 6. Okay, secant is the, oh, go ahead.
Why are we assuming it's the 4th quadrant, not the 3rd quadrant?
I hear your question, but remember for inverse sine and arcsine that it's restricted. Okay. Secant is the reciprocal of what function? Cosine. So that would be the reciprocal of the x, right? So I need to do 1 over 2 root 6. And when I rationalize that, you only have to multiply by root 6 over root 6. So 1 over 2 root 6 times root 6 over root 6. And I get root 6 over 12. Is that what you guys get?
Yeah.
Okay. All right. I want you to try number 15 on your own now. What quadrant will you draw your picture in for number 15?
First quadrant.
Very good. First quadrant because it's positive. So try drawing your picture in the first quadrant, solve for your missing side, and then see if you can figure out the tangent. All right, number 15. You drew your triangle in the first quadrant. Take a look at your triangle. Did you start your triangle at the origin, like that? And then adjacent over hypotenuse, and then you had to solve for your missing side, the y. So 3 squared.
Wait, how do you know which numbers are where?
So cosine is the ka in SOHCAHTOA.
The adjacent's the A.
So this is the adjacent, and this is the hypotenuse.
Okay.
And the hypotenuse is B, right? I mean, the
C, yeah.
C, and then the opposite's the B.
Okay, so I got root 7 here. Did you guys get root 7? Oh, yes, thank you. And then the tangent is y over x. So what did you guys get? Root 7 over 3? Good.
So after you find that out, you find the tangent.
Okay. All right, let's just do one more. Do you want to do 16, 17, or 18?
Tan's opposite over adjacent.
Tangent is opposite over adjacent, yes.
So that's root 7 over 3.
Yeah. 18? Okay. So let's do 18 together, and you guys can look at 16 and 17 on Blackboard. So tangent is in first and fourth quadrant. So which quadrant would we put this one in? 4, thank you. I don't have a ratio, so I'm going to make it -2 over what? 1. So -2 is opposite, and 1 is adjacent. Or you could say -2 is y, and 1 is x. And then we're going to do Pythagorean theorem. So I get root 5, and remember that the hypotenuse is always positive. So now I need to do the cosine of theta. So opposite over hypotenuse, and rationalize. So what questions do you guys have on 18?
Wait a second.
Go ahead, Christina.
It's cosine, so it's like adjacent.
Okay.
So it'd be like 1 over root 5.
I appreciate it. Yep, you're right. Positive 1 over root 5. Thank you for paying attention. And that would be positive root 5 over 5, right?
Yeah.
Thank you.
Wait, so how did you get your, so what's your hypotenuse for,
So the hypotenuse is root 5. I found it with Pythagorean theorem.
and what was, and you already got your adjacent?
I already had the adjacent, yep.
Oh, because it's just -2 over 1.
Yeah.
Wait, why?
Why do we change the numbers? Because I accidentally did opposite over hypotenuse, but she pointed out it should have been adjacent over hypotenuse. All right, so you already know reciprocal functions. If you want to type cosecant, you do 1 over sine. If you want to type secant, you do 1 over cosine. And if you want to type cotangent, you do 1 over tangent. However, it does not make sense to do 1 over inverse sine for inverse cosecant because you would be taking the reciprocal of an angle. That doesn't make any sense to do the reciprocal of your angle. So what you do instead is you do inverse sine and you take the reciprocal of the input. Okay? So in this case right here, it would be inverse sine, and the reciprocal of 8 is 1/8. That's how you would type it on your calculator. For inverse secant, you write inverse cosine and the reciprocal of the input, and inverse tangent and the reciprocal of the input. So I'm going to write the first three out, and then you guys are going to type them in. This one is going to be inverse tangent, and then you flip the input. And inverse sine's actually on your calculator, so you're going to type that exactly how you see it. All right, so you need to grab your calculator and make sure you're in radian mode. All right, press mode. If you're in radian mode, you're good to go. I'm going to type second sine, 1/8. So no, you're rounding to the nearest thousandth, okay? So remember decimal, 10, hundredth, thousandth, third place, okay? So I got 0.125. All right, next one, I'm typing inverse tangent. 12/5. 1.176. And then the third one was like all ready to go. So inverse sine, 0.987. 1.409. All right, let's look at some of the harder ones down here. Instead of typing secant, I'm going to type 1/cosine. But instead of typing inverse cosecant, I'm going to type inverse sine and flip the input. So it would be 1/-7.234. All right, so I have two sets of parentheses there. That's a tough one.
So we're actually doing 1/cosine.
Yeah, so you're going to do 1/cosine, and then you're going to do inverse sine. Okay, so I got, this 9 actually rounds up, so it's going to be 1.010. All right, and then you can find the rest of those on Blackboard.